guys, welcome to 3.2. Before we get started on this one, we're going to do sine, cosine, and tangent today. And before we get started again, we're going to talk about some definitions, some vocab, so that we can get better at this trig unit. There is a lot of reading here, so I'm not going to read all of it to you, but I do want to get to the definitions. So standard position. In the coordinate plane, an angle is in the standard position when its vertex is at the origin and one ray of the angle lies on the positive x-axis. So our positive x-axis is this part right here. That's what we consider the initial side of the angle. And that's what puts us in the standard position. So when our initial side is on the positive x-axis, then it is in the standard position. The terminal ray is the one where the angle ends. So it says here the terminal ray is the second ray of an angle in standard position. So it's going to be where our angle ends. And this right here would be our angle. So initial side, when it's on the positive x-axis, it is in the standard position. So these are in the standard position. And then the terminal ray is our last, where our angle finishes. And then this right here would be our angle. Most of the time we talk about it as theta. You're going to see a lot of the Greek letters as we move on in our trig unit. Now, notice that it is going counterclockwise. That is when the angle is positive. If our angle is negative, again, we start on the positive x-axis right here. That's our initial side. But here we're going to go clockwise. Then my angle here is theta, and it is negative angle. It starts on the positive x-axis, and it moves this way, making our terminal ray right here. Now, real quick, I'm going to talk, we'll talk later about it as well. But if these two landed in exactly the same place right here in the second angle, this one does not since this is a little bit higher, but let's say they were both on the same exact location, those would be called coterminal. So the positive angle, let's just say 150, for example, right here. And if this went all the way this way, we could say the negative 210 are coterminal angles because they land in exactly the same spot. All right, so sine, cosine, and tangent is what we're going to talk about in this, or we're going to focus on in this section. It's something that you talked about in geometry, but we're going to talk about it with the triangle inside of our circle here, in most cases in the trig. It tells us that the sine theta is the ratio of the vertical displacement of P from the x-axis to the distance between the origin and the point P. So our distance to that point P would be this right here. That's the radius of a circle, so we've labeled that as R. And then the vertical displacement from the origin to, from the x-axis to that point would be this part right here. This is my vertical displacement. Since this is 0 right here, whatever my y value is going to be the length. So my radius would go from here and this one would go from here. That's because if you remember in geometry, sine is opposite over hypotenuse. So recall that's opposite over hypotenuse. And so if this is my angle, the opposite would be this one, and then my radius would be the hypotenuse, making this the 90-degree triangle. So cosine of theta is then the ratio of the horizontal displacement of P. So my horizontal would be this portion right here, or they've got it labeled on this side. That's the horizontal displacement from the y-axis to the distance between the origin and the point. So again, my distance to that point would be this portion, which is the hypotenuse and the radius in this case of the circle, since my point is on the circle. And so this is adjacent over hypotenuse. And then the last one that you learned in geometry was the tangent. It is the slope of the terminal ray, the ratio of the vertical displacement to the horizontal displacement of P. So the word slope is in there. Remember rise over run from Algebra 1? That's basically what it's telling you. Tangent is the slope. It is the rise over the run right there. So that's my y over x. Also known as the opposite over the adjacent from geometry. And so it is the opposite over the adjacent, which is y over x. So those are some that you need to know. This is one of the identities we'll get to, and they've got it listed here just so that you see it. Since sine of theta is my opposite over hypotenuse and cosine is my adjacent over my hypotenuse, then tangent being opposite over adjacent is also the same thing as the sine of theta over the cosine of theta, so you can start recognizing it as that as well. All right, so let's get to some questions that look like that. Here they are giving us a circle on the top, right here. And again, we have a point P right here. This is my angle. And then this would be the radius of my circle. In this case, we know that the radius is from the center of the circle to any point on this circle. So by labeling this at 3, 0, then I know my radius is 3. If this is 3, this is also 3. So I'm going to go ahead and label that 3 right there. All right, so the question says the figure shows a circle centered at the origin with an angle of measure theta in the standard position. The terminal ray of the angle intersects the circle at point P. The coordinates of P are x comma y. So this would be my x comma y. Which of the following is true about the cosine of theta? All right, so cosine of theta, we said, is the adjacent over the hypotenuse, which is the x over the radius. My hypotenuse is right here, the radius. My x would be this portion, so we're looking for the cosine value to be x over 3 in this case. So we can definitely take out these y values because that's sine. And so here's my other two options, and I would know it is A, that's the one that's got x over 3. This would be the radius, which is the hypotenuse over its displacement. All right, let's look at the next example here. And it says the figure shows a circle with a radius 5 centered at the origin with an angle of measure theta in standard position. The terminal ray of the angle intersects the circle at point P. Find the following values. And so my point P is right here. We're going to have to put a little more thought to this one. So we can see that the radius is 5. And so from here to P, it must be 5. So our hypotenuse we already see is 5. Now, if this point is 3, 4, and it's a 90-degree right here and right there, then I know that this point right here would have to be at 3, -4. It is on the positive for the x, so all of these x values are the same, so that's where I get this 3. Now, this point would be a reflection across the x-axis, giving me that -4 for the y. All right, so now we've got this point of 3, -4. Here's my angle all the way around. But this is a triangle that helps me my reference triangle for this point. So we are going to find the sine, the cosine, and the tangent. So we said the sine is our y over r. And so the y value there is -4, and the radius is 5. For my cosine, we said that's x over r. And so my x value is 3. My radius is still 5. And then for my tangent of theta, we said that is y over x. And so my y value would be -4, and my x value is 3. So there is my sine, cosine, and tangent for that one. All right. For our next one here, says the figure shows a circle with a radius r centered at the origin with an angle of measure theta in standard position. The terminal ray of the angle intersects the circle at point P. The coordinates of P are x comma y. The points Q, R, and S are the result of reflecting point P across the y-axis, the origin, and the x-axis respectively. Find the coordinates of the points Q, R, S in terms of x and y. So since they are reflections, these are all points on the circle. So we know the radius from the center to any point is just r. since they did not label it anything besides R. So we know this part is R, this part's R, this part's R, and this part's R. Now we're looking for these points right here. This is a reflection across the y-axis. And so the y values are all the same along this horizontal line. So I know I'm going to have the same exact y value. The change is going to be in the x. Since it reflected over here, we know that the x values are positive on this side and negative on this side. So this would be a negative x, positive y. So my point Q is negative x, positive y. We've reflected again to get to this point right here, or you can say reflected it this way across that origin. And so that's going to be negative x and negative y, because we go negative on this side and then negative as we go down. And then my last one would remain a positive x, because we are still on the positive x side here, but this is a reflection, so my y value is going to change to a negative y. So there is my coordinates. Now it says find the sine of the angle whose terminal ray intersects the circle at point S. So this is my point S right here. And actually, I'm just going to go ahead and write the terms here, the coordinates here as well, so I can see them for our answers here. So point S is this one right here. So this is what we would use. It is asking for the sine, and so sine is the y value. So I would say negative y over my radius. The next one says find the cosine of the angle terminal ray, point Q. And so point Q is this one. For cosine, I need the x value. And so I would say negative x over my radius r. And then the last one is the tangent of r, which is this one right here. And so tangent is y over x. And so I'm going to say negative y over negative x, which is positive y over positive x, because a negative divided by a negative. All right, let's go deeper into these sine, cosine, and tangent values. It says let theta be an angle in standard position whose terminal ray coincides with the line y equals negative 3x in quadrant 2. Find the following values. I'm going to sketch a quick little picture there so that you can see it. There's my circle. Negative 3x would look something like this. And so it tells us that it coincides in quadrant 2. So we're looking at this one right here. That's where quadrant 2 is. Okay, so I'm going to put a little small note down here so we can think about some things. So we've created a right triangle right here by finding that vertical displacement and the horizontal displacement. Since it is a right triangle, we know Pythagorean theorem, that's x squared plus y squared equals r squared. Now it told us that y is negative 3x right there, so I can go ahead and plug this in. And then we're going to go ahead and simplify. When I square this, that is negative 3x times negative 3x, which gives me a positive 9x squared. So we add that together and we get 10x squared equals r squared. To get rid of the square here so I can solve for my r and I can know what the radius of this circle is, I would take the square root. When you do that, you end up with plus or minus the square root of 10x squared. Since it is in quadrant 2, we know we're looking for that negative part. And I'm going to go ahead and simplify. Since it's a distance, I can leave that there as 10 root x. Sorry, I just wrote that backwards. That's x root 10. Sorry. And I just did it again. X root 10. So there is my radius. All right, so now let's talk about the sine of theta. The sine of theta is our y value over our radius. And so my y value would be negative 3x, and my radius would be x root 10. And we're using the negative because it's on the second quadrant. Now, the x's are going to cancel out, and the negatives are going to cancel out, so we get 3 over root 10. You guys need to rationalize this. We're going to rationalize when we do these. We do not want to, which means we do not want to leave a square root on the bottom. So we would multiply both the numerator and the denominator by root 10 to rationalize. And so we're going to get 3 root 10 over root 10. But we'll do that later on. So this is a perfectly good answer for right now, but just know that in the future we will rationalize. We're not going to leave the root 10 on the bottom. All right, for cosine of theta, we're looking for our x value. And so we can say here, x over that negative x root 10. And so my x's cancel out, and we get negative 1 over root 10. And so there is our cosine of theta. And then our tangent of theta, we're looking for that y over x, which we said was the same thing as the slope. Remember, that is our rise over our run. And so we can just look at this right here. That is just negative 3 because that would be the rise over the run. Let's look at our circle. Our rise over run to get to this point right here. All right, so here is 2 more circles for our final ones. It says each figure below gives a circle in the xy plane with a center at the origin and an angle theta in standard position. Find the value of each expression. So we want to find sine of theta, cosine of theta, and tangent of theta. And so just like we said before, we can create a vertical line here for our right triangle in this. And that will give us our sine, cosine, and theta. That's considered a reference because this would match the same one as the other side. So we can do x squared plus y squared equals r squared. And so I get a negative 3 squared plus 1 squared equals my r squared. That gives me 10 is equal to r squared. And so r is equal to the square root of 10. So for my sine of theta, that's my y value. So that's going to be 1 over my radius, which we just found was the square root of 10. Again, we're going to start rationalizing. So we would multiply times root 10 over root 10. That gives me root 10 over 10. Because the square root of 10 times the square root of 10 is the square root of 100, which is 10. That's called rationalizing. It's getting rid of the square root in the denominator. And so for my cosine of theta, my x value is negative 3. My radius is the square root of 10. And so we get negative over root 10. We rationalize, so we get negative 3 root 10 over 10. And then for our tangent, it is y over x. And so we get 1 over negative 3. So the first thing I needed to do was find that radius. All right, for our next one here, I don't have to use Pythagorean theorem because they have given us the point right here on our circle. So I can see that the radius is 6. Since this is to the origin to a point, then my radius here is also 6. And so that creates my right triangle right there. And so my sine would be my y value, which is negative 5.4 over my radius of 6, which is negative 9/10. And if you put that in the calculator, you're going to get negative 0.9. For my cosine of theta, I'm going to put my x value. So that's 2.6 over 6. That's 13 over 30. And if you put that in the calculator as a decimal, that would be 0.433. And then for my final, my tangent of theta, I'm going to put my y value over my x value. And if you put that in the calculator, you get negative 2.077. You do want to leave 3 decimals. This one did not come out to 3, but if there is 3 decimals, you want to make sure you're leaving it at 3 decimals at least. All right, so that is our sine, cosine, and tangent lesson.